SPI 12.1, we're looking at how electricity can be produced using a magnet and a coiled wire. Okay, to create an electric current, you only need two things. You need a magnet, and you also need a coiled wire. Okay, so before we go into the details, I want to show you what this looks like. Okay, so I also want you to label yours on your paper. Okay, here we have a magnet that has a north and a south pole. Okay, and here you have the coiled wire. Okay, that's all is required to make an electric current. Okay, to prove that we're creating an electric current, okay, we're going to hook it up to a meter. Okay, and here's a meter. We're going to find out here in a little while that there's different types of meters. We're mainly going to talk about two different kinds of meters, okay? Alright, so a magnet produces a magnetic field with a force that pulls or repels other materials such as iron, cobalt, and nickel. And what we mean by pulls or repels, if you put a north pole of a magnet to a south pole, they're going to attract each other. They're going to pull towards each other. However, if you put a south pole to a south pole, or a north pole to a north pole, those are going to repel. They're going to push apart from each other. Okay, so that's what we're talking about here. Alright, the next thing is a coiled wire, is wire that has been shaped to have a spiral, okay, or a sequence of rings or circles. And beside of this sentence, I want you to draw your loop-de-loops here, okay, and that's what we mean by making wire into coiled, to coil it up. Okay. Electric current is a flow of electric charge, often that's carried by moving electrons in a wire. So I want you to underline electrons. So you should know what those are after we've talked about atoms. Okay. The next thing is we've got meters. Okay. I told you there are different types of meters, and meters measure the amount of electric current that's flowing through a wire. Okay. Now we've got two different types of meters here. We've got a microammeter and a galvanometer. Okay, these are the tools that's used to measure the flow of electric charge in a wire. There are different types of meters. Okay, here I've only given you the two as examples. These are two of the most common that you will see throughout questioning, and that's in your textbook, and that's on the web. Okay, these are two of the most common used when making electricity, just using a magnet and a coiled wire. Okay, here's some neat things about when you are producing electric current using a magnet and coiled wire. You will find out that the faster you move the magnet, the larger the electrical current is going to be. Also, the more coils that you make in the wire, the larger the current is going to be. Alright, so down here at the bottom you see 4 pictures. We're going to label those 4 pictures. Okay, so here you need to label the coil, you need to label that's your magnet, that's the two things that's required, and the third, this one, label it as a galvanometer, okay, and that's one of the types of meters. Okay, moving on to your second picture, label the magnet, label the coil wire, label the meter. Okay, now this looks completely different than the other two images that you've seen, but it's the same process, and I'm going to write this out for you. This is actually a fixed magnet, okay? Before, the magnet's what moved and the wire was what was held in place. This one's different. The magnet holds in place, and I'm going to show you here. So here you have a north and a south pole, and you need to label this on your sheet as well. And then here, do you see that wire? Okay, they use that handle then, almost like that of a fishing rod, okay? As it spins, you can see the arrows here on the illustration. It's the wire between these two magnets that turn. And when that happens, believe it or not, it's the same process, just this time the magnet is fixed opposed to the wire. It will also produce an electric current. Okay, and they call this the coil effect. Okay. Alright, here's one more. So label this also as a fixed magnet. And you can see these are horseshoe magnets because they look like horseshoes. So label your magnet, okay? And then here you have your coil, okay? And it moves up and it moves down, and that also produces an electric current. Okay, guys, if your name starts with, first name starts with the letters A through J, put a star in the bottom left-hand corner on this side of the sheet. Again, if your name, first name starts A through J, put a star in the left-hand corner, bottom left-hand corner. Okay, now we're moving on to SPI 12.2, and we're going to be looking at electromagnets. Okay, so the SPI reads, describe the basic principles of an electromagnet. All right, here we go. So electromagnet is electromagnet has a metal core that's made into a magnet by the passage of electrical current, okay, through a coil surrounding it. So let me first go into the materials that you need to produce an electromagnet. You need a battery, you need a metal core, and we'll be using an iron nail, okay, throughout class as our metal coil, excuse me. And then you also need coiled wire. Okay, so this one is different, okay, here because there is no magnet involved in making an electromagnet. So out of these three materials, you're actually going to produce a magnet, okay, that has electricity running through it. So we'll look at that a little more in detail. So here is an illustration. Okay, here is the iron core, okay, which happens to be a nail. Okay, here's your coiled wire, and here is your battery. Okay, and we're going to find out the function of these in a little bit at the end. We'll show you what an electromagnet does, it uses. Okay, so current must flow through a wire for it to work properly. At the end of that sentence, I want you to write that you have to have a good positive and negative battery connection. So the wire has to be connected. One end has to be connected to the positive. The other end has to be connected to the negative. You have to have a closed, what we call a closed circuit. Okay, they're connected for your electromagnet to work. Okay. So, how could you test the strength of a small electromagnet? What you would do is you would attach a spring scale to the object that the electromagnet is picking up and measure the amount of force it pulls with, okay? And of course, you should know if you're using a spring scale, you're going to report that in newtons. Okay, in that sentence, I want you to underline electromagnet. Okay. All right, the strength of an electromagnet can be increased by adding more loops in the coiled wire or by using a larger, more powerful battery. Okay, so you can actually increase the strength of an electromagnet by just adding more loops to that coil, or also adding a stronger power source, such as a bigger battery. Okay, so electromagnets are widely used as components of electrical devices such as motors, generators, relays, loudspeakers, hard disk, MRI machines, scientific instruments, and magnetic separation equipment. Also doorbells, believe it or not, many of those actually work through electromagnets. So you may never see the electromagnet in some of these devices, okay, but their components actually have electromagnets in them, okay. So here's one of the most common. I wanted to show you this picture, okay. We ever seen this? You can see it's picking up something huge in metal, and you can see it being sucked up to the electromagnet here at the top part of the screen. The idea I get in my mind when I think of electromagnet is that big magnet that reaches down and like picks up a car at a junkyard to put it where it goes to be smashed. Okay, that tool right there is a huge electromagnet. Okay, this is a type of train transportation system, and believe it or not, if you look at this track, they use electricity running through it, and by changing the poles of the magnets will actually allow this to move forward on the track. Okay, so really neat type of technology. Okay guys, this is it for SPI 12.2, and we will be making electric current in class by using a magnet and coil wire soon, and we will also be making an electromagnet in class soon to see how many paper clips that we can pick up. Okay guys, that's 12.1 and 12.2.